Okay. So um, we are going to be looking at some few things today. This is a heat map. I'm not sure I showed all of us this kind of graph or this kind of plot. This is a heat map. A heat map that what is it I generated is towards class attendance and then the marks that you get at the end. So let me close it entirely. So today, like I'm saying, we want to look at things that has to do with machine learning. But for us to be able to get this quite well, there are some few things or some few functions that we need to learn how to use them. Machine learning is basically about two things. That is, you put the data into two parts. Then we have one called the training data, and we have another one called the testing or the validation data. So you use part of the data to train the model. So you're going to build a model, but you want to use your part of the data to train the model, and use the other data to see whether the model will be able to identify or will be able to use that new data. There are instances that people have the training data, they have the testing data, and we have completely external data for testing to see whether the model will be able to predict to accuracy or not. But there are some few parameters we need to know about. What are some few inbuilt functions that we need to know? So today I want us to have the other ways or the other inbuilt functions that we need to know about, let's say, machine learning. So I don't know if has any of us been hearing of machine learning and we don't really know how the thing works.
Yeah, I've heard machine learning before, but I never knew what it was about.
Okay, great. So machine learning is basically the way human beings learn. The name machine learning is like allowing machine to learn things like the way human beings are learning. For instance, if all of us are sent to a botanical garden, when we get there, we are going to be introduced to most of the things, or we are going to see a lot of plants and shrubs and other vegetables around there, and then we begin, to look at them, to look at their characteristics, and then we are learning. We are learning how they are, how the colors and whatsoever. Later on, when we happen to see the same plant anywhere, because we already have seen the characteristics and we know it, we can say that this one is a shrub, and this one is a plant, this one is a vegetable, this is a tree, this is a crop. Only what the pollinator will understand the differences of what I'm mentioning. So that is what we call learning. Now, on the other side, scientists have come out with a plan to be able to allow a machine or like a computer to also learn. How does a computer do that? You have a data set or you have data that you have collected over time. The computer can also look at the data and observe the data over time, observe every single aspect of the data, and the machine will get to realize that, okay, it has learned. It has actually also got itself acquainted with the data and knows that anytime I see that somebody is buying bread, that person also buy butter at the same time. So the machine can say that, well, bread and butter are bought at the same time because the machine has learned. So the machine learning is actually like subjecting the machine to going through a data and identifying patterns. So when it has identified the pattern, then the machine can then build that particular pattern. But let me say this, machine learning actually came from the traditional environment. Let's know this. Machine learning came from our traditional people. For instance, my mother can tell me that it will rain in the evening, and it will rain. Yeah, if all of us, those of us who grew up in the villages, the village people can actually observe the weather and tell you what will happen in the evening, and it will happen. How do they do that? They look at how animals behave, they look at how birds behave, they look at how insects behave, and they watch trees. So machine learning actually came from local environment. How do they do that? When the trees, the leaves, decide to turn in a particular manner, it means it is responding to environmental changes. They do not have those things to be able to measure that. But they are able to realize that, no, anytime this leaf turns this way, it means that it always rains in the next 3 hours. But nothing will tell them that anytime the leaves are turned, it means humidity is high. You see? So they learn over time. And anytime in our place, we have a bird called Yitu. Anytime that bird is crying, you know that it's likely to rain in the evening. Why? The bird body can respond to environmental changes. So when humidity and temperature whatsoever reaches some point, the climate changes, and then all these animals, they respond to it by making noise, by flying around, by doing a lot of things. And the village people have used this to become like, or they have learned this thing over time, and they know that anytime they see, okay, these birds flying up and down and doing this, they know that it's likely to rain. In fact, they even look at the way insects move, and they can tell that there will be heavy harvest for millet, or there will be harvest for yam, and then there will be this for this and this and this. That is machine learning. It's actually, people call it artificial AI, artificial intelligence, or the traditional AI. So the traditional AI, this is the same syntax that they use. So machine learning is basically like allowing the machine to have access to whatever data that you have, and then it will assimilate the data and identify the patterns, and later on, anytime that pattern comes, it will say that, okay, this is what is happening. So we are going to be doing one maybe from tomorrow, and then what we are going to do is we are going to pick a data set, and then we will throw the data set and write an algorithm, and then we will throw the data set into the machine, and the machine will begin to be learning on the data, and later on it's going to print out whatever pattern it has identified. This pattern it has identified is called a model. That's a model. A model is simply like representing a data in a two-dimensional format, where you can actually see who is related to who and who is not related. And that's why when the model is built, we can say that, okay, the model can predict, the accuracy is around 90%, which means that if the machine identify that, okay, all those who are buying bread, they also buy butter, something will let you know that, okay, there's 90% chance that anybody who buys bread will buy butter, but there's a 10% chance that the person will not buy. So we can say the model has 90% success of prediction. So that is the same thing that is being used in all the AI that we are seeing. In self-driving cars or whatsoever, we are using machine learning. Now, the machine learning comes in two different forms. We have supervised learning and unsupervised learning. The supervised learning aspect is you have to describe the data variables to the machine and say that, hey machine, these are human beings, but when you see any of them wearing blue, black, the person is in KMSC Business School. If you see the person wearing black and violet, the person is in agribusiness. If you see the person wearing this and this and this, then those descriptions you have already given it to the machine. So anytime the machine then sees somebody and the person is in that color, the machine will simply report that the person is in this particular department of the university. And that's what machine learning is doing. It's practically used for prediction. It's practically used to represent your data in a two-dimensional format in such a way that it becomes clearer. And so now the next thing will be like, after you have done that and the model is built, what happened next? What happened next is that it's a code that you have written, and that particular code is able to have 90% accuracy of prediction. This particular code is now written on what we call the microchips. Now, if it was meant for like doors that open itself, then the microchip is now incorporated in a camera, and the camera is fitted to the door. Now, anytime the camera spots a human being, then the characteristics of the camera will pick all those characteristics and send it to the microchip. The microchip will find out and relate it to the data or the function that was already built sitting there and say that, okay, this is a human being. And the function is saying that if it is a human being, then something will happen. Just like we were doing if statement, then the door opens. So that's machine learning, and these days it's very important because it incorporates every single bit of the data. I'll be discussing it small. So we have supervised learning and unsupervised learning. For the unsupervised learning, the machine, you just give the data to the machine. The machine will go there and identify its own pattern. That one you have not described anything. So you just sample all the students in KNUST, and then you give it with their characteristics, and then you tell the machine that I want you to use these characteristics and identify A, B, C, D. At the end, the machine will group them. So we have, I think I have about 20 slides that I will have to do on this machine learning, and then we all can get it clear. Today, I just want us to have glimpse of most of the petty things that we need to know, the inbuilt functions that are related to machine learning before we get there. But when we get there, I will do the 20 slides presentation for us to have a clearer understanding of all that machine learning is doing, and then deep learning, and then the neural network that we have. Then we can go ahead and get a sample data and build one model, and you see, we can even simulate our own data and build a model. I think I have a data set on food distribution, the way people patronize food in the northern part of Ghana. I think I'll use that one. I simulated the data for like if you were selling kuli, you were selling sobolo, you were selling bisam, and the northern part of Ghana, different markets. So that's what I'll be using. All right, so let's kickstart and let's see. So the inbuilt functions in R that is related to machine learning are just too many. I'm not too sure we'll be able to finish all of them today, but I believe that we'll be able to do that. So let me see, where am I going to start? Okay, yeah. So the inbuilt functions, one of them is substructure split, pattern, partitioning, replicate, repeat, and then there will be other inbuilt functions that we'll look at. So the substructure or the subset, how to be able to subset, is very important. For instance, if you have a data like what I have here, you can just create, let's say, a vector on your computer like this. If you run it, and then let's say that you want to print the data from the third variable up to the seventh variable for here, so you can use the substructure function to be able to do that. So if I run this now, you see that it's going to print from the seventh from the third position up to the last position, and this function will be using it a lot when we get to that particular place. It's actually very easy. Let's assume that if I were having a data frame, if I were having, I don't know whether I have built any data frame here, but if I were having a data frame and you want to just pick a portion of it, just to subset, you can use substructure to be able to do that. The only thing is to identify the column, and then identify from which position to what other position, and then you can print it out there. For instance, if I have, let's say, if I have this, let's say it's just my name, I'm just going to write my name in continuous, but because it's their characters, I could just say that's my name, then I could move like this, and then, but if you move like this, now if I run this, it runs all right. Now if I use the structure, then okay, where am I? If I use the substructure like this, and then I put the vector there inside. So first of all, you have to put the vector there and give it a space. The second thing is, from where to where do you want to print? So this is the entire thing, but I want to print only big bar. I don't want to print bright. So what I can simply use 3, or no, sorry, I'm saying 3. I can simply use, so B here is from the first position. So I'm going to come here and then say 1. So I'm printing from 1 up to which particular place? Up to the sieve. So if I do, if I come here and then I put up to 6, if I run that, it's going to print only big bar. It will not print the other name. Now, let's assume that I wanted to print big bar and then add only B to it. What do you think would have been here? If you are watching, that's one of the functions that I want you guys to pay attention to. Substructure. It's very important, especially when it comes to this data science, machine learning, and stuff. So here, you just have to create the vector. If it is a data frame, identify the column, and then you know from which particular position to which position you want to print. And then when you do that, if you run that, it will simply print that for you. It can be a whole lot of, like, it can be a whole sentence. Or like, I could have just say, is the instructor of this, let's say, this particular program. So now I could just, go and print is the instructor of. So all you need to know is which particular position does I represent, up to which particular position does R represent. So you just have to count them, and then you put them accordingly, and then it will print only the last 3 words, and that's all. There's a different function that can let you. Yes, please.
Please, the space is not counted, right?
The space is counted. So let's assume that I am going to say B1, BB1 to 7. So let me run that again and see. You see that it printed big bar, and then there's a space in front of big bar, right? So, but if I do here 8, and then I run it, then it will now print big bar B. So which means spaces are counted, right? That's one of the functions. The second function that I want you guys to pay so much attention to it is partition. Partition. This will be using this thing so much, right? So let's assume that I have a vector called Y, and then I'm just going to create I don't know, let me just create some random let me just use run if and create some kind of numbers. So let me say I'm just creating 100 data points, and then I want the minimum of 2, and then I want the maximum of 60. So I'm going to run that into, and that is it. So now I can partition it, and then what I'm simply saying is that I want to partition the variable called Y. But what is the probability that I'm going to use? I am going to use, the probability is going to be based on this particular vector. That is 70% and 30%. And the seed is 1. Let me run it and you see what is going to happen. Okay, what is it? The function partition is not there. Let me see what if I can. I'm trying to get the function partition. I'm sure it comes with a package, and that's why the package is not maybe the package is not activated or it's not installed. So what I'm going to do, I will just find out. Okay, now you guys, you find out for me. I think it should be part of the learning. Just Google or just check on your side which package contains partition. Which package, which R package contains or comes with partition. Or you can say, yeah, any of the packages like and then let's see what is. I'm also going to Google on my this and see. So what is it? Because I'm using my two streams of data, that is why if I Google, it takes time to come. But it's one of the things you have to pay attention. Anytime you want something, as to how to be able to get it is very important. So I'm running a function called partition, but that function is not there. So I want to activate it. So I don't know what to do. So I'm going to find out whether there's a package I need to install before the function partition will work. So I'm just going to find out. So what is it? A package comes with it could be that the partition itself is a function that you need to install, or is a package you need to install. So I could just try and find out. So I'm going to check here. So I'm just check. Well, I've seen partition there. Yes, so I'm trying to install it. Yeah, it is installing right now. So it means partition itself is a package. Okay, so I think it is now. So I'm going to check over here, and I'm going to say partition. Looking for it around here. Okay, if I'm not getting it, I'll just library it around here, and then I'm going to say partition. It is there already. Run it, and then hit library. So let me come back here and run this code and see. There's an unused argument called seed is equal to 1. So let me take that out and see what is going to happen. Then let me run it again and see. Error in partition underscore direct or operator is valid for atomic vectors. Okay, so I want to do. Okay, I could look at. I mean, how do I get to know? Yes, please.
Whilst Googling, I found out something called RPAT.
R what? R what? Paths. R path. This one.
Yeah, part. Yes.
And so, did you get the usage?
No. For fitting recursive partitioning models.
Okay. So now let's do this one and then get to that one. So we're going to do like this.
Okay.
And then we can question partition and then look at how it's being used. Okay, so now you have the usage is here. I mean, we can all do this, do question mark and then partition, and then it will go to this side on your right bottom window. So it will tell you how it's going to be used. So you have partition followed by data, followed by the threshold, like a partitioner is equals to path, and then all those things. So now the data is supposed to be a data frame. Okay, it's supposed to be a data frame. So that's one reason why this one did not work. It's not a data frame. Why should have been a data frame? Why should have been a data frame? All right, but in any case, we can also subset this particular data that we have here. So it means that if we are not dealing with a data frame, it might be difficult for us to use partition. But if we are using other kind of data, we can also be able to use different ways to subset it. Now let's leave the partition here because there's a data frame down there, so we'll use it over there. So let's assume that I have this particular Y already, which I have here. I mean, I could use this how the Y is looking like. There's a whole lot of data over there, but it's not a data frame. At least, well, why don't we form a data frame and try it and see whether it will work? So I have YY, and then the YY, I could just do like this, and then come and say I want the square root of the Y already, and that become YY. So in that case, I could have a data frame like this, and then that particular data frame, data dot frame, and then the first one should be Y, and the second one is YY. So the data frame is now there. So in place of this, I'm going to put the data frame there and see whether it will work. Error in partitioning again, operator is invalid for atomic vectors. I think the syntax is still not correct. All right, so let me try other ways of doing the partitioning before, or the other functions. This, for the sake of time, maybe as we go along, I will get to know how to we can get to use it. But I noticed that it could have just been seed equal to 1. I was coming to explain that. Ari is saying that I don't really need it, that I don't need the seed, which I thought it should be there. So if I come there, if I have a data frame, the threshold, so okay, so there is a whole set of how to use it around here. Now, if you have already checked how to be able to use it, so this is one of the ways. So this is a data frame, and I have simulate underscore block, and so I am partitioning 3, 4, 5 with the lower like 40%, and then the upper is also given, I don't know, I can't see the other side. Okay, the other is 60%, and the number is so let me try this one and see if the code will work. Then I can replicate whatever that we have done here. What I am doing right now, I think you guys will pay great attention to it, and so that anytime you get stuck, you know how to go about your own things, and then you'll be able to. So now I have my data frame here, so which has been partitioned. Oh no, I have my my data frame here. So if I have the data frame and I want to partition, So I could say partition data frame threshold is equal to 0.6. So maybe this is how the syntax should have been. So let me copy that part, and I'm going to come here and put it there and do this. So now if I run this, that it means I have partitioned it, and then I have taken only 60% of the data around there. So that is over here. So now let's follow the same syntax like we have here and go on top there to see whether our data frame here we can partition it. So the function is partition followed by this and then threshold. So partition followed by this, and then instead of using this, I'm just going to take out all of them and say threshold. And then the threshold, let's say we are partitioning by 0.4. Then I need to close that up. All right, that works now. So that one is working right now. So that's one of the ways to be able to do partition. I think that even though we got it wrong, but it's good that sometimes in data science it's sometimes very good to get some of your things wrong. So out of if you now want to know how you can get out of it, one of the ways is to check whether the function is there or not. And we checked, and we noticed there is a function by itself that we need to install, a package by itself we need to install. We installed it, and then we loaded it. But I followed the syntax still. That one didn't work. So what did I have to do? I decided to use a question mark to be able to get to how to be able to use that function properly. Any function you install in R and you load, if you want to know how to use it, put a question mark in at the back of it and run it. Go to usage down there. They will give you examples as to how to be able to use it. And as we can see, there are quite a number of examples as to be able to use partition, how to be able to partition your data and whatsoever. Do quite a number of them. So that's one part that we need to what we have paid attention to. There's another another thing that I want us to pay attention to: absolute. For instance, if you have your data that comes with negatives and positives, and you don't want the negatives to be there because you are actually dealing with absolute values, you can just pick up that particular column, and then you say that, okay, I don't want anything like any sign to it, so you use absolute to do that. You could use square root to do the other things, ceiling and whatsoever. Now this part called truncates, all those that you are seeing here, they are all part of the things that we need to know. So I could use my absolute to take my negatives away, because this is important, because during correlational analysis, if you may generate your correlations and then there are negatives, but you want just maybe for some reason, maybe you didn't want the negatives to be there, so you could actually take out the negatives. Or maybe you are dealing with humans, and then later on maybe the results is coming, or the data you are dealing with, there are some negative and whatsoever, you need to take that out. You don't have a negative human being, you need to take that. You need to just use absolute to take that out. This one, square root, I've already done that. This now, this ceiling and then floor, that one is like the way we run up and then we run down. Now this particular function, let's pay a greater attention to it. Truncate. Truncate means you don't need the decimals, so you use the truncates, and to print only the absolutes or the integers. So let's assume that if the one that we had done here first, the y that we're having here, if we had printed, you could see that it was full of negatives, decimals and whatsoever. So we have that particular one there. Let's come down here and say that we wanted to truncate it. So we could just come down here and say truncate. and the truncate comes there. Let's put the y inside, and then when we do this, you see that we no longer have anything like they now come without the decimals. That's another inbuilt function that we'll be using it a lot to truncate. Now, there are instances you want to normalize the data. Some of the data can come with the variables are so much like when we say to normalize the data, you have so much variations which may not be outliers, but there are too much variations in it. So sometimes you always want to take a log or the anti-log to be able to normalize the data. This is very important in genomic data analysis. You have to sometimes normalize, especially if you are doing polygenic risk score analysis. So let's say I have this particular a vector. So if I run it, the vector is all right, but I want to find the log. So I could actually find the log here, and then the log will normalize it. So if you check here, we're having 5, we're having the highest of 7 and the lower of 2. Now come and look at the log. The log tells you that almost everything that has about 1 point something, 1 point something, 0.6, which are quite closer. Now, if I decide to do a plot, if I decide, okay, now if I pack this here, or if I decide to say S, and then I do this, so the 2, do the 2. So now let me come here and say, I just want to plot, X7, and then S. So look at the graph. So you see that it's almost like, you can see the points are almost on the same line. So that's for normalization. If you didn't do what normalization, you are not always able to get the exactitude of whatever that you wanted to do. It's not in all cases. There are instances that your data, you are required to be able to do that. Now, the other thing here is like exponent, I think. So the exponent, you could actually use the other exponent we're using different functions, but this is actually the way to do an exponent of all of them. This one, we've already spoken about this substructure. We know how to be able to use it. So if I run this, so it will simply just print the range that I wanted. Now, the other function, very important, is substitute. Imagine that you've sent people, hey, am I talking alone or you guys are there? Okay, I've seen that you are. There are instances you can just, you send, let's say, you were dealing with a data set, and that data set is something that keeps changing. The names, like, okay, you are looking at all the managers in that particular facility. But some of the managers, they are being replaced. Some have gone on retirement and new ones have come. The data will have to be updated. This one is very important when you are dealing with system administration. You have to be updating the data over and over. The simplest function to do that, is what we call substitute. For instance, I have a whole stretch of a vector here, and I say England is beautiful, but not parts of EU. But I want to replace England with UK. Alright, so I simply just run this out. Then when I go, I am substituting England with UK, and then this is the data. The data is actually ST, or the vector is actually STI. So I could do that, and now if I now run that particular code, you see that England is replaced with UK. So you see that UK is beautiful but not part of EU, right? So you could do that for like Kumasi is the capital of Ghana. No, I've noticed that this is a mistake. That's a blunder. So what am I going to do? I am going to replace Kumasi with Accra, and this is the vector where I want to do that particular replacement. So if I do that and I use substitute, yep.
The syntax does not allow you to bring the vector before
Yeah.
the change that you want to do, right?
Yeah. So what is substitute? The data comes last. And I'm happy you've asked this question. So pay attention to those kind of things. There are instances the syntax says that the data comes first. Mostly in data visualization, the data always comes first. Any other thing away from data visualization, sometimes the data comes at the last part. But whichever way, always be ready to find out how the thing is being used. If you want to know how what substitute is being used, just put your question mark and then do substitute. You see here? When you run it, arrow will tell you how to use it exactly. So you can see here we have grep with grep1 and then a substitute, and this particular function I'll be using it a lot. The gsub, I'll be using it down there. What don't worry yourself, because it's another thing that you can pick your data and you see comma. Some people, when they are entering data, it's like they're crazy. You see comma there, you see full stop there. Any data scientist will tell you that those things, the package, you identify them as characters, and that's going to be a problem. All right. So you can see gsub here, replacement pattern or whatsoever. That's how to be able to use it. But all these things, we'll check them that they are down there. So this is how we substitute. We substitute something for another. What is it for another thing? But what about there are instances you also have, you want to you've written down a lot of things and you want to split them to individuals. Let's assume that I just decided to create this particular class. This class, for instance, class is a function, so I don't want to spell class the same way so that it will conflict with the function. So I'm going to say this is our class here. So I'm just going to put our names there like this. If I come out, no, I'm just going to put our name without comma or whatsoever. So here, then I could just put this, and then I could just put now when I am done, if I run this, all of them are there, but I actually want each of them to stand alone. That's why we use what the function called structure split. Structure split. All these functions I'm talking about, they are part of individual things we'll be using in machine learning, and that's why I want us to have grips of them. Structure split. All right. So if I come here, if you now use the structure split, you can even see quite a number of them, and then that comes there, and I want to split what the class. All right, here. So it will now pick all of them individually. Okay, sorry, I should have done this and then comma there, and then I just split it into. So I want them to be separated. So if I do this, let me run it and you see something. This is interesting. Now I'm going to run the second one. Now, the two, Paulina, these two, when I run the first one, I'm using the same function. When I run the first one, look at how it splits the information. All right. If I run the second one, using this the vector A, and I split the vector A, look, this is how it splits it. What the difference? Where did the difference come from? What is she's asleep? Mohammed.
Yeah. Let's in between the quotes.
So I mean, so what does that mean? I get you. What you are right.
So the one you left space is telling the up to place the name, not the alphabet.
Okay. So the one, if I leave space here, I am telling R that I want you to split them word by word. If I don't leave any space, I'm telling R that split them character by character. So if I wanted to have, then I'll just do like this and run it again. You see that now everybody's name stands as a character. Everybody's name stands as a word, just like the way they are. So that's one thing. But what about sometimes curiosity kills the cat? Let's add another space and see what's going to happen. Now, can you see what has happened?
Yes.
It will print it. This is when you use what is it? The structure split function, and you leave two spaces in between the double quotes. It's the same thing as using a function called cat. This particular function called cat. Cat means print exactly the way the thing is. So if I say cat here, and I put into bracket, I do this. If I decide to type anything within the bracket, cat will print it exactly the way I have. That's how it is. Now, if you don't want to use cat, you can use the structure split, and then leave here two double quotes. Two spaces in between the double quotes, and it will do the same thing. Okay, just attention to that. So, what is that? I've already explained that. So here is the same thing. We could actually split it the way we want. Okay. Now we also have strings. String. There's a string. So we have a structure split. The string. Okay, is practically the same. Now we also have instances where you pick people's names, and then they are in lower cases. You want to bring them to upper cases. That one is just to say to lower to upper. This one, if I do this, if I identify the column with the names, and then that's all. So it will simply turn everything to small letters, and then to lower. Okay. Now this is meta-analysis. We are not going to do this one today. That's meta-analysis in R. So I'm skipping that part to the last part of what we are supposed to be doing today. So Mohammed was asking me of funnel plot. So that's your funnel plot here, but we are not dealing with that today. That's the funnel plot. You could actually see how that works subsequently. So here, this place is another important place. All of you have heard of this before. So we have the R-norm, the whatsoever. This one here, we all know it. That's data simulation. Data simulation. Just remember, you might ask me, why are we doing this again in machine learning? I just told you that in machine learning, we split the data into training data, sometimes validation data, testing data, and then or validation data. Depending on which one comes first. Now, when you split the data into two, mostly people split the data into two. You have built the model, you have tested it, but you want to validate the model. So to validate it, maybe you need an external data that is completely alien to the data set that you are using. So you need to be able to know how to simulate data. Data simulation is a whole topic by itself. One of the ways to simulate data, we've already done it, but maybe I didn't say that data simulation, is by how to be able to create your random numbers. For instance, if Paulina, you have a data set right now, and you don't want to be using that one to try your analysis, you just look at the pattern and then simulate your data accordingly. and then you use that one to practice, to do all that you want to do. And if everything works perfectly, then you now push in your real data into it and then run through. This is how almost every data scientist do. They don't go ahead and start doing try and error on the main data. When you do that, there are instances on functions when you run, you cannot reverse. It's going to change the data entirely, and it will be difficult for you to take to the each point. So let's simulate your data, simulate it accordingly. So if this particular column, I know that is dealing with integers, the highest is this, the lowest is this, I can create random numbers what are within that particular range, and that's all. I move to the next column, simulate the same way, the next column, and that at the end, if it is a data frame, I create my data frame. Then apply all the functions that I'm supposed to apply and all the analysis that I wanted to do. Then all the results will come. When the results come finished and you are okay, you are set with everything, then you now pick the real data and now come and now follow the course and then run them down. This is a simple trick. Don't ever forget this. So let's know how to be able to do that. So we are simulating some data here, and we already know how to RNorm when we're doing normal distribution, remember. So these ones we are just, I'm just, what is it? So I could just create some random plots here to be able to see what it is. So this is another way of doing data simulation. You could use sampling. So when we have done our machine learning, when we do our training and our testing, we are going to simulate the data. We ourselves are going to, so I'm going to do the model as an assignment to simulate the data, and then test it, and then test the model, and then tell me what the result is. So that's why I'm not wasting time doing this. So you can use RNorm, PNorm, depending on the type of data. If the data set or if the numbers that are in that particular column is not a normally distributed, don't use RNorm. And by now, we all know how to be able to test whether the data is normally distributed, it's not normally distributed. So before you simulate, expect that if I'm going to use, if the data is in the form of binomial distribution, don't use RNorm, use PNorm. You see? All right. Okay. All right. So you can also use sampling, depending on how your the data set is given. So you can use sample to be able to do that. We all can remember sampling the pick replace without replacement and whatsoever. So let's say that this data set, we all should know about it. The Irish data set, it comes with so many things. So I just printed a little bit of it. We'll just pick the head, and then we look at how it is. Okay. This is the most commonest data set that a lot of people have used. Just hold on. But in this case, let's say I wanted to sample, so I'm just sampling 1 to n row. So I'm just sampling from 1 to the n row, what is it, of that particular data, and I'm just picking only 10. So if I print that out, this all in connection with data simulation. All right. So if you count here, there are only 10 things that we have. Just so that's another way of sampling from a data frame. You just simply indicate. Okay, so I think this one's here, because we already know how to do sampling, I don't have to waste a lot of time here. There's something really very important that I need to let us know, and I'm looking at that. This was okay. I think we also know something about repeats. Okay, so we want to repeat teaser 20 times, repeat fufu 30 times, and repeat banku 50 times. So you see, when I do that, I can print. I'm actually rushing to get to this point where think it was Mohammed who asked me that question. When you do matrix, you see that, or data array, you see that the entries are almost like, okay, now let me leave it and then let's get to this place. So I can sample X, which equals to food, and then size 10. So now if I do this at random, I have done some kind of sampling. So you see how the data was created. I just decided to repeat TZ 20 times, repeat Fufu 30 times, and repeat Banku 50 times. Alright, so if I print the whole thing and pack the whole thing to food, but I'm not saying that I just want to pick 10 of the foods at random. So what am I likely to pick? I like sampling because if I run the sample again, here, the results will be, it will not be the same. Check and see. The first one, Banku TZ. The second one, Banku Fufu. So that's what is actually sampling is all about. It should be random. So I'm just saying I just want to pick 10 of the food items and see which one I'm going to pick more. and that is it. So like I was saying, this one is the Poisson way of like doing random sampling. I'll send all of you the code, so you don't need I don't need much explanation here. Then the sequence here. So I am sequencing 12 what is it? Data variables to, let me run it first. So I have 12 plus 5, 17 plus 5, 22 plus 5, that will be 27. So I am sampling beginning with 12 and ending at 30. And the sequence is that I want each variable to be different from the other one by 5 steps. Let me pause here and ask a question. Where do you think this kind of data simulation will be very necessary in machine learning? Or just at normal times? Where do we think we need sequencing is very, if you're going to simulate a data, what kind of data will you be simulating that you require a sequence? You have to use a sequence to do that. Let me be sure that. Oh, what is it? Mohammed is not around. Are you guys there?
Yeah.
So, Paulina,
Yes.
where do you think we need sequencing when we are doing sampling? When we are doing data simulation.
Maybe if you don't want data with natural, like a higher standard deviation, there shouldn't be much variation.
Okay. Eben, what if you are if you have a data? Okay.
Please come again. Then maybe
if you wanted to simulate a data, or people say simulate, right? Simulate a data, and then what kind of data will you require to, use sequencing to be able to? Just think about what kind of data that has, a regular interval. So they differ from each other by a particular gap. So the gap is the same. One is different from the other one by either 2 or 3. All of them, they differ from each other by 3. They differ from each other by 2. They differ from each other by a constant. What kind of data? At what point do we have that? Let's think about it. Okay, what kind of data? Index numbers. Am I right?
Yeah.
Yeah.
Okay.
Index numbers have regular interval. What is it? Student ID. You wouldn't know the interval, but they are following. They are following each other. So the interval could be 1, could be 0.1. Now, sequencing data is very important when people are writing functions for precision. For precision. For instance, those who design this, very difficult, sit somewhere and go on lunch. Or let me use a very good example, not to use a bad one. Like air traffic control. Most of the functions that are written there, they use sequential. Because the aeroplane and the other aeroplane must move at a particular distance. It cannot go beyond that. If the distances are not the same, or if the distances are not by that particular regular interval, then there will be a crash. So most of the functions that are used in air traffic control apps, there must be a specific sequence. They use sequencing to be able to simulate that kind of data. That's another way. Because the distance between one plane and the other, whether altitude or distance, it has to be the same. It cannot go beyond that. Aeroplane move at constant speed. When they take off and then they tell you that they were moving at this time, that's why they can tell you that, okay, we'll be in Belgium by 6 p.m. in the morning, 6 p.m. in the evening, and they are there. Sequence. All right. So now the other parts that we need, this is the last part, is the difference between repeat and then replication. To repeat and then to replicate. You even have to pay attention here, because in hospital, this data is much more simulated in hospitals. Repeat and then replicate. Now, how do we use repeat and replicate to simulate data? Check something here. I have a name here. I'm going to repeat whatever that is here. Let me run it and see. No, the syntax is not correct. The syntax is not correct. Yeah, I actually tried it last night and it didn't work. Here, I want to repeat 19 times. So here, I could have just taken out one of them. Or I could have used another. And then I'm just take the vector out. Yeah, this one could work, but because of the... Yep. Great. I don't know why I left that code there. Maybe I wanted to say that you should correct the error. Because somebody actually informed, somebody watched the video and sent me a message that I don't always create intentionally errors for my students to follow, to correct it. And I said, well, I should have a tutorial on that, how to correct errors. Okay. So I want to repeat my name 6 times. I'll do this. I want to repeat 19 times. I've already printed that. If you can remember this function called lattice. What is it? Lattice. So I want to use that one to show you different ways of repeating. So I am just going to, I've just created from C up to the last one, P. Now, let me come and use the functions here. And then you see what that means. Now, if I say repeat, this is the function, whatever that is here. And I'm saying each is equal to 4. What I'm simply saying is that I have in ABC, 4 is what? A, B, C, D. 4 is D. So I am going to repeat each of them 4 times. Each of them is going to be repeated 4 times. So DDD 4, EEE 4, up to the last one. I'm going to pause here and ask a question. For this place, you will follow, and then you would, then I will do the first one, you do the other one. Now here, Paulina and Eben, you are online. Do this. How do you then create I want you to use any of the random functions. Just replace it around here and leave the rest. Let's say run if or sample. To see whether if you can use a repeat to create a group of let's say some group of something or something. So let's say I want to create some numbers. Let's say 5 to 10, then 11 to or let me say 1 and 2 in a particular sequence or something like that. This is what I'm trying to say. I'm using repeat here, so it opens. So I want to say that I want to use run if function. So if the run if function comes in, so I want 2 numbers or 3 numbers with a minimum of 1 and a maximum of 2. That's one of them. Then when I come out, I want to use another function called sample, or let me leave it at this point. And then say that, come here and say each equal to, let's say 4. Run that and then see what is going to happen. Great. Now I have managed to, this particular function is going to create 3 numbers between 1 and 2. But each of the number that is going to create is going to be repeated 4 times. Each of them. So you see that 1.3, 1.3, 1.3, 1.3. Then 1.9, 1.9, 1.9, 1.9. Then 1.3, 1.3, 1.3 again, up to the last part. So this is the first part. I want you to also try with this particular function that I have here, but add another function inside. Right after this here, you could have added, let's say, comma here, and use another function inside, and see what you are going to get. Try that and let's see. I'm also trying. So I have repeat here. I could actually use repeat within repeat. So I have repeat here, and I want letters. I want capitals. That's the first one. So I'm just going to do this and say, how many letters do I want? I want the letters from 1 up to 6. Sorry. I want 1 up to 6. Okay? So when I come out of it, I put comma. And I said, I want to also say run if. And the run if, I also want 6 variables. And I want the minimum to be 20 and the maximum to be 60. And I want to repeat each of them. I want to repeat each of them by 4. I want to repeat each of them by 4. Okay. So I'm going to say each. I hope my each is well spelled. Each is equal to, let's say, 3. Run that and see. There's some invalid argument, error in okay. So whilst you are doing yours, let me see where I got mine. So I have run if here. When I finish. Come again.
I need to go to that one and attend to something. And the appropriate time I can get a bus in 10 minutes time, else I have to leave for an hour time.
You say what?
I want to go to town. So I'll else I'll wait for 5:30.
So you want to leave right now, right?
Yeah.
Okay. Then what is it? No problem.
I'm still on.
No problem. Come again.
I'm still online. When I'm leaving,
Okay.
I will just log out.
Okay. All right. So what we could come and look at another part here. Maybe that this was the first one. So I have repeats. You could also have this. The times means you are going to look at the group. You are going to repeat the groups. This one is not. So you are repeating each set 3 times. So from 3 up to 8. So let's say from C up to a particular maybe F or something. We are repeating that 3 times. So that's repeating a group. This one is very necessary somewhere because when we do that, so I'm going to copy this and then come down here and paste it there. This time around, I'm going to change the word each to times. So the times will let us see that we are actually repeating this set of numbers 4 times. So if I run this, you see, I'm repeating each set up to a number of times. So C, D, E, F, G, H, and then again E, D up to the number that we are, that it is required. So let's come and run this one with times. So it's also going to repeat each group according to the time that has been given. So there are instances too, you want to repeat the numbers based on the length. Maybe the length is about 1 million. So it will keep repeating the groups until it runs out. So let's say you wanted to put constituencies on regions. So you started that you want the first 2, 3 constituencies, this. So until you get to the last one. So you are just going to have a length. So it will continue repeating until the length 17 reach. So it will repeat again. And so this one too the same. That's the same. That's the same. Okay, so you could actually do this in so many ways. Like I have here a data frame that could use that to create a data frame. The same way here, I could use it to create a data frame here. So now if I can simply print this data frame and you see how it looks like. So you have the group, you have the responses. So all those who are in group D, the group D, these are the responses. This is group E and their responses, group F and that's their responses. So let's say this is a kind of data you have picked that are in groups. So after that you can decide to check within the group comparison and then outside group comparison. So you see how that is. You have the groups here, you have your letters, each of them 3 times. So you also have the response. You can use the R norm, this and this and this, and then you go and say maybe this. So you can form a data frame of it. And that's one beautiful thing about using these letters. It can help you to be able to represent your data, simulate your data in whichever way that you want. Another one is here. Let me run that, and then you see that's how that will work. You print that data set. So it's the same way. You have another 2 groups there. Around here, you could have 3 groups. So if we print that, that comes in the form of a data, a data frame. So you have a group here, you have a factor, and you have a response. So in group A, factor C, you have this response. In group A again, but this one, the factor is different. So the same group, different factors, different responses. And then you have how many groups? 2. You could do this for like 5, 6 groups. Now, those of us in a group, you could have a group of treatment. Like you are not just looking at only one treatment, but you are looking at the combined effect of different treatment on a particular variable. So all of them are going to be in a group. So let's say group of nutrient fertilizers, then group of insecticides. Then maybe let's say when it comes to weeding, when it comes to humidity or watering and whatsoever, you want to test the individual impact, and the group impact. This is how you are able to simulate that kind of data. That's why I'm saying that this part of this work, I really love it, but I know it can be a bit boring. But trust me, it's very, very important that you pay attention. So if we run this is a data frame that we have with all the groups. But in this case, this is the group that we are representing. So if I print the data set out, you will see how that also looks like. I'll fold this up. So here we have 2 major groups. And look at the outcomes with X and then the Y. All here are CCC group. Here are DDD group. Okay, I wanted to finish, and then the time is running. So another another one the same way. I mean, the most important thing is for us to know how to be able to simulate our data on different ways. Trust me. Now that's it about like repeats, how you can use repeat. But there are instances you want to use replication. Replication, the difference between repeat and replication is that replication takes expression. You want an expression, the expression is going to bring you some kind of output, but you want to replicate the same expression several times. So if I have here replicate n is equal to this, so we are going to replicate the number of times is 3. And what are we going to replicate 3 times? This particular expression inside here. So the expression is, we want to use rnorm to create 5 variables with a mean of 0, standard deviation of this. And we are going to repeat the same thing how many times? 3. So run that, and that is it. So if I fold it up like this, you can see that we have replicated the whole thing 3 times. The same way with the others. But here, we are saying that simplify is false. When you say simplify is true, it's going to print the data in a matrix format. So you see that it's in the form of a matrix. And so in this case, let's assume that the data set you are dealing with was in the form of a matrix, and you want to simulate the matrix data. So this is, you use replicate to be able to simulate matrix data. And then before you can now use your real matrix data. Okay. So if you put true at the end, it will give you a matrix. If you don't put anything, it's going to give you the same matrix. But if you want it to come as vectors, just say simplify is false. And that's why I put on top there, I say the simplify means output format. How do you want the data to come out? And then that is it. So I gave an example here. So let's say SIMList. We are going to replicate 3 times, and then we have our expression, and the expression is a data frame. So we have a data frame, and we are saying that the group will be equal to, we are replicating letters 1 to 2, that's AB. And each of them is going to be 3 times. So AB, AB, AB 3 times, that's about 6. The response, we are going to use these 6 variables, and then that's all. And the simplify is false. So when we say simplify is false, they are going to come as individual. So if I print SIMList, I'm going to have each of them being printed like this. So it will come in the form of a data frame, and that's how it is. So I have that's another way of also using replicate to be able to do your data simulation. Okay. So I think that the last parts, I think I will have to stop here. God willing, tomorrow I'm going to manage to get 1 hour at workplace, so that we'll be able to start it from somewhere. This one, the last thing, I mean, you are the only person left, right?
Yes, please. Yes, please.
So the last thing that I want you to pay attention to, let me quickly get to that data without. The last time I showed you data cleaning, it was only about how to remove your NAs. They're not available. But there are instances you can find data set with comma, with question mark, with brackets here, with different characters. In fact, when people are entering data, it's like they are always drunk. It's crazy. How do you be able to remove those things? To remove all those small characters. So that's what I'm going to show you briefly, and then what will part company. All right, so it's here. It's part of data reshaping. I didn't realize that I needed to add it when we were doing data cleaning, but I noticed that with this one, we need it. So I have a vector here. Then when you use something called structure replace, so we are going to replace, now here, this is the data. Here, we are going to replace something with something. Okay, let me run it and you see. Oh, structure replace, but the function is not there. I don't know what's is. It should be there. It doesn't come with any package. Oh God. Okay. I think I need to activate a particular function. Yeah, the function is not activated. I don't know which structure replace. It should be there. Oh God, oh God, God.
So it's in a package called string R.
String
R. Yeah.
Yeah. Thank you. I think I've got it on my. I've installed it. I was getting. Yeah, it's here. Yeah, let me activate it. Thank you. Okay. So now let me run that again. So I wanted to replace BB with Bigba. Yeah. So this is the vector. I have BB, I have B, and I have Kwanla. So I want to replace BB with Bigba. So you say structure replace, bring out whatever the vector is, the name of the vector, pick out whatever you want to replace first and what you want to replace with second. Now I want you to pay attention to something. This thing, data science, is always tricky. You just use your intuition and you will get it right. Let's assume that you were having this vector with these characters. If you are able to get this right, I'll just close from here. And then you notice that there is a exclamation mark. When I'm tired, I don't see things. Then the next one is okay. The next one is okay, like this. Okay, so but have you so let me run that. If I print it, if I print DD, you notice that no, the last character, there is something attached to it. You want to remove it. You get what I'm saying? You want to remove only this.
Yeah.
So what I'm going to do is, this was the first one. The first one, I was having a character here called BB, but I wanted to remove one B and leave the other one. So what I will simply do is I simply say structure remove in this particular vector, and I say remove B. When I do that, it's going to print the vector, but you won't see BB, you now see only one B. So you see it's now B. In this example, I'm giving it because of this. You can see people names and then there will be at. Somebody can put there at like this. The thing is there. You see, all these things may not be necessary. You want to clean your data. That's another interesting way of cleaning data, using this structure remove, structure replace. So if you come here and you wanted to remove the ads, you could just say, let's say, what is it? Structure underscore remove here, and then what are we going to remove? We are going to DD, comma. What are we going to remove?
The at.
The at. And we need to put it in what? Like this, and say at. So when we do that and we run, you won't find at again. So you see that the name is now intact. Now you can actually do this. The last class I was teaching, I actually gave them a data set that it was my personal data set. I actually was doing comparative, and then the other data set is full of comma, is full of this useless things. So I will ask you to how to be able to remove all of them. So if this was, we have something we call structure remove and structure remove all. So if it was, let's say, a whole variable or a whole column where you have all these characters, you just need to specify the specific column and then specify that character that you want to remove. It will go through and remove all of them. In fact, if you notice that that particular character is found in the entire data frame, specify that data frame, put that particular character there, and arrow will check around and remove all of them. That's what, yeah. So this was a data set. It's called ML. So this was how to be able to to replace. So I noticed that no, I needed to change the name Egypt before this to Egypt this. I didn't want the underscore again. So it will go through the data set and change everything there, but I have not imported the data. It's multi-locus sequence typing data that I imported, and I give it to this. So it was an assignment. So you could actually check how to be able to do all this remove. So at a point I say I don't want all these things Egypt.faster file, this. So remove everything called faster. Then it will remove everything. In Linux, there's something we call wildcards. That's what we use in removing them. But here, we only just use this one. In Arrow, we use this remove. But I beg you, this is the very last one. I'm not going to drain you again. You see that this one we are removing some characters like dot faster, at, and whatsoever. It doesn't work in all of them. There are instances you want to remove a character like a square bracket or a bracket. It won't go. Let me show you one example. So here, let me create a vector like this, and then go and use characters. So I'm just going to say I have let's say I have square bracket of food, then enclose it with another square bracket, and then open another one and say that I have brackets open again, and then I'm going to say meal, and then bracket close. Run this. The object not interpretable. Already there is a problem with it. R is finding it difficult to even understand what that means because of this. Now let me just remove one of them. But you can import a data with that kind of thing. When I imported my data, that was what we saw. And we have to use this structure remove and whatsoever. But this one is not working. It's not working. So I won't be able to demonstrate for you to see because R will not permit me to do it. But you can import a data and
remove at that stage, it will not be able to.
It will not. So you use this particular function called gsap. Gsap removes everything in this world. There's nothing it cannot remove. So at any point at all, you see that these characters, for instance, that my data, every single variable was having these two things, this square bracket and then bracket in between them. All right. So what I needed to is to say use the gsap, and then I am removing this. So if I use the gsap here and I come and put this empty quotation marks without any space, I am simply saying that remove what I take it out and replace it with nothing, and it is found in this particular vector called vector 3. So it will take all of them out. It will go through the whole of vector 3 and remove anything that is square brackets and this and this and this, and then replace them with nothing. So that's how you are able to clean things like tilde. There are instances you can see tilde. You can use that one structure remove to be able to move it, and then whatsoever. So these are the very few things we need to know when we are simulating our data, and then this last part is just the additional way of cleaning the data and getting it in shape. So I think it's almost 5 minutes to 4, so I will leave it here, and then God willing, tomorrow we will try and see how we can apply some of the things I have said today. Meanwhile, I will arrange the course in order of how we just did it today, and then I will add the descriptions to it and send it to all of you. So thank you.
Okay.
Okay.
Thank you so much. And
Okay.
last our agreement was that we'll do weekend classes only.
Yeah. Okay. Then I could just. I was thinking that because yesterday we missed, that's why I was thinking of like getting a small time to replace that part. If not today, we won't be doing this. Yesterday was planned for this, and today would have been the actual machine learning. But because we couldn't do, that's why. In any case, no, there's no problem. Well, when we get to the other weekend work with, then we can try that. Okay, so I'll leave it here.
Thank you
Yeah.
so much.
Bye bye.